Now, let's take a close look at these neon lamps. These lamps are both lit, but they light in different ways, don't you think? Well, you may have realized what these lamps are connected to. The one on the left is connected to a battery, while the other on the right to the power supply unit for alternating current. Now, let's carefully watch how this neon lamp here, connected to the direct current power source, is lit, and also the other one here, connected to the alternating current source. Now we move the lamps horizontally to study how the lit conditions of the two lamps differ. Have you noticed any difference here? Well, it may be a little difficult to see it precisely in this condition, so we'll photograph the two neon lamps to make it easier for you to compare their movements. First, the direct current. In the case of direct current, the movement of the neon lamp is shown on a straight line. Now with the alternating current. You see, the alternating current makes it like this. Large and small rings are alternating. The above on the screen shows the case of direct current, and the one below is the case of alternating current. We'll now study the same using a rotating mirror, with mirrors alternately set in position on its four surfaces. We turn the rotating mirror, holding the neon lamp closely in front of it. Let's begin with the lamp connected to the direct current and see how this lamp reflects on the rotating mirror. Next, we try it with the one connected to the alternating current. How does it look now? We've just filmed it to observe how it looks with the rotating mirror. This is the case of direct current. And here's the result obtained by the alternating current. Next, we'll have a little test using salt water mixed with phenolphthalein solution and filter paper. First, the filter paper is soaked with salt water, which contains phenolphthalein solution. And then a test lead is connected to the direct current source.
No problem.
No, sí, no sé. No sé para qué.
We draw a straight line on the filter paper with the test lead. Now here appears a straight line like this. Now you look at it carefully again, will you? The straight line appears only on one side. This time, let's connect the test lead to the alternating current source and do the same thing again.
Yeah, that's the only
Here we see two dotted lines. Do you see how the two dotted lines are alternating? Here's what happens with the direct current. And this is the result with the alternating current. You can clearly see how the dotted lines are alternating. Let's compare these neon lamps. The one lit with the alternating current, as you see, is in the middle, with the surrounding area in an alternating manner. This is an oscilloscope. We'll make studies on the respective wave patterns affected by the direct and alternating currents using this oscilloscope. First, we connect it to the direct current source. This is the wave pattern affected by the direct current. Next, we see how the wave pattern will be resulting from the alternating current connection.
What is a bondage, man?
This is the wave pattern created by the alternating current. Now we look at the respective wave patterns made by the direct and alternating currents at the same time. The above is the direct current pattern, and below the alternating current pattern. This steel cord is coiled with enamel wire. Its tip is connected to a dry battery. Now we switch it on. Oh look, they're stuck together. The steel core has become a magnet, putting an iron plate above. While the direct current is working, the iron plate stays stuck. We'll now try it with the alternating current. Let's raise it to, say, about 6 volts. Now we switch it on. It goes up and down, this time doesn't it? When the alternating current is affected, the object does not only sticks but also separates and repeats this movement. This is a rectifying circuit which transforms the alternating current into the direct current. We'll study the processes one by one. First, the original alternating wave pattern is shown here in the upper portion of the screen. Let's try it now. The wave pattern below is the initial pattern, and same as the alternative wave pattern above. Secondly, the input current is adjusted in one direction by means of diodes. Now, more adjustment with increased diodes. In addition, the use of condensers and resistors will modulate the input amplitude. Now it has been smoothed out to a great extent. Now look, the one above is the original wave pattern of the alternating current, and the one below is the wave pattern of the rectified direct current processed by the rectifying circuit. Here's a model car in motion. Well, what do you think is the trick inside it? We'll just open it, shall we? This is a selenium rectifier. This model car doesn't run by the alternating current, so we've got to change it to the direct current by a rectifier. We'll just try it by connecting the selenium rectifier to the alternating current source. We now raise the voltage, and you see the model car runs. Such a simple device can rectify the alternating current into the direct current and set the model car in motion. It's really surprising, isn't it?
O sea, que la AC puede electrificar la DC y entonces funciona como un AC.
AC es modificado con la cajita esa azul para convertirlo en DC. Que fue lo mismo que hicieron en la cajita.